Back to the class of Math 1450, and this time we are moving into a new topic from expressions to equations. First of all, to be clear, what is an equation? When we have two expressions and they are the same, that tends to be an equation. Okay. When you set two expressions to be the same, and you get an equation. And we mentioned that there are so-called linear expressions. So accordingly, if you have two linear expressions tend to be the same, and then we are having a linear equation. So in this section, basically it is expected you got to know what a linear equation is, and you know how to solve a linear equation. And also we'll talk a little bit about inequalities. Actually inequality it is the next section. This section it is only for equations, and it is only for linear equations. Okay. And let's just move on to the example. First example, and this is taken directly from the textbook. This is the equation I'm talking about. It is linear, and also I'm not sure if it's a little unusual. I mentioned earlier we use notation x a lot, but any letter would do. Okay, certainly x, y, z. These are the popular choices, and n could, well, we do use n, like in this example. N it is for a number. N it is for number, and we want to solve for n. And also, I say this is not a big problem at all, right? But it is still fair to say you cannot just claim you can see the answer from the equation directly. You want to follow some rules. So this is what I did. Follow the rules of order of operations. I see in parentheses, starting from left-hand side, I remove the parentheses. And then I try to follow the rule. Remember, combining like terms. I have numbers combined. Okay, first I have parentheses removed. And then I try to combine like terms, these two like terms. And also the other thing, to solve an equation, basically you want to have the term with the unknown, unknown notation together. So in this case, there's only one term with the unknown notation. So you want to single out this term, 7n. That's what I did. And then in the end, I figure out my answer, which is 2. N equals 2. Okay. So it's a very simple problem, but it does take a few steps. And also, in general, when I solve an equation like this type of problem, basically all the operations I did, there are two operations. Okay, when you have an equation, you can add both sides of the equation by a same number, so the equation still stays the same. This is the so-called the addition principle. And remember, we have addition and subtraction, and then we can make it the same statement for subtraction. But let's say we understand addition and subtraction really the same. Okay. And similarly, we do have the same rule for multiplication and division. On the notes, I just listed this as a multiplication principle. In words, we can say if A and B are the same, and then A times C it is the same as B times C. And certainly C cannot be 0. If we see 0, it won't make sense. Okay, but the C could be positive, could be negative. And indeed, I really want to see C could be a fraction. Okay, C could be a fraction. When C is like 1/2, 2/3, basically it really means when you multiply like 1/2 or 1/3, basically it just means divided by 2 or divided by 3. Okay, so this is about the way how we solve equations, and especially for linear equations. There are two principles keep in mind. addition principle and the multiplication principle. Even though as I'm saying 2 only for addition and the multiplication, I hope you do see really subtraction and the division works in the same way. Okay. And one more example. This time we have the notation y. It is example 5.13 on the textbook. So we solve this problem. Solve for y. Solve for y. First, I remove the parentheses. Right? And then I try to combine like terms, 9y and y. And also there is a 7y from right, okay? But anyway, for the moment, I just kept the 7y untouched to the right. And to move the 7y to the left, you may also change the addition to subtraction. But anyway, if we use the addition principle, we really should say it more precisely. I'm adding the term negative 7y to both sides, left on the side and the right on the side. And certainly right on the side, the 7y is cancelled, okay? And in the end, we find out the solution of y. Solution for y. And also sometimes we need to handle the equation with notations, not only one notation, multiple notations, okay? So this is the distance formula. Basically, it simply says the distance, it is the speed multiplied by the time traveled, or it is the rate or the speed. D is for the distance, T is for time. And this time the problem says clearly we want to solve for T. So you want to focus on T, single out this T, take out this T, okay? So first what I did, because I want to have a single T, I multiply both sides by 1 over R. Or if you want, I can say I divide both sides of the equation by R, which is just the same as saying multiplying both sides of the equation by the reciprocal of R. So indeed, in this case, to this point, T it is already singled out, okay? But write in a better fashion, because usually when we write an equation, we say, okay, T equals 1, X equals 3, those things. And to see that clearly, I want to say the formula for T in terms of distance and the speed or rate of change. T is D over R. T is D over R. And one more example for this section. Yeah. It is solving for H. This is the area of triangle. Area of triangle, it is 1/2 times the base times the height. And we want to solve for H. I suppose it should be pretty simple thing, right? And basically all I did to solve this equation, I just used the addition principle and the multiplication principle. Okay. It should be straightforward thing to follow what was provided on the notes. And in the end, we got this H in terms of A and B is 2A over B. 2A over B. Thank you for watching.